Hi, and welcome to Geeks for Geeks. Give me a quick one in the chat if I'm audible as well as equally visible, and then we would be starting off. Give me a quick one in the chat. Okay, fair enough. Let's quickly start off. So before we start off, for those who don't know me, I'm Siddharth Hazra. I'm a senior software engineer here at Geeks for Geeks. Besides that, I'm also a mentor over here, and I primarily deal with system design, DSA, competitive programming, and all those stuff. And that's pretty much about me. I did a bit of competitive programming too. I'm an ICPC regionalist in Amritapuri region. So that's good enough to start. I would just quickly share my screen at this point. Just a sec. Yup. So my iPad screen should be visible to you shortly enough. Just, yep. So now my iPad screen should be visible. Okay, fair enough. So the very first thing we learned was relational databases. Okay, relational databases. What was basically relational database? If you observe, relational databases are, as of now, and we know that relational databases are just another table with relation and these all things. But now let's talk from an eagle view out there. Okay, today we would be learning about how to scale up a database, why it is most critical one. So relational databases, we would talk about first relational databases, we would talk about scaling relational databases, and then we would move on to non-relational databases and scaling them. Okay, so first let's start about relational databases. So if you observe, databases as of now is the most critical component of any system. They can make or break a system. Okay, basically we data in an save data in an application using databases, and it is one of the most critical. If you observe that without our data, Google is nothing. If you observe, just an application, even though Google is so big of a company, without our data, Google is nothing. Why? Because let's talk about maps. If Google Map doesn't have the location or the data stored out there, we won't be able to navigate in maps, because there is no use of navigating. Google Maps doesn't really know where to navigate and where you want to go. If you talk about search engines, if they don't have the websites that they need you to recommend, there is no use of it. So where we are saving the data, it is one of the most crucial part out there. Okay. So in relational databases, data are stored in rows and columns. Okay. Data are stored in rows and columns. Okay. Now, a little bit of history about relational databases. Okay, so what happens was that initially we started off with financial applications. Okay, like financial applications started to automate out there. Okay, initially nothing was on internet. The very first thing which started off was financial. Why? Because everything, the core of everything, most of the thing starts with finance. Okay, so what happens was computer first started doing accounting. Okay, started doing accounting, and there a very important part was done, that is using ledgers. And this using accounting on internet, compute doing accounting on computer and using ledgers, they started thinking that why not take this ledger out there and keep it out there in the internet and let's save it. That is where the birth of rows, a table with rows and columns, erupted. A table with rows and columns did erupt. Okay, so the databases were developed to support accounting. Now, to support accounting, what are the things that we require? The ACID properties that we have learned very back out there, like data consistency, data durability, data integrity, constraints, and everything in one place. Okay, and that is why, because of these all things, because of financial things, database relational database provides something known as transaction. Okay, they provide something known as transaction, and we have talked about transaction in the past. Okay, the very important thing which I wanted to double click over this, because if you remember in the past classes, we talked about that yes, this is something known as isolation and these are the isolation levels. But if you talk from a very eagle view out there, if you're designing a system, if you talk about databases in terms of system design, then this is one of the important thing. Okay, what is that? The I of acid, that is isolation. Okay, what is isolation? Let's first think that this is transaction 1, this is transaction 2 out there. For this, let's say we have 4 5 lines, and for this we have 3 4 lines out there. Okay, now when we are at this line and this line we are at, how they should behave with each other. Okay, so this line I would just write it over here more. Okay, should changes at this line in transaction 1 visible to transaction 2 before transaction 1 commits. So if you observe, what do you mean by commit? Save it to the database. That's the meaning of that. So should the changes done at this line, done at this line, be visible to transaction 2 before transaction 1 commits itself. So should this line be visible to transaction 2 at this line? So when two transactions are running, how much they should be able to interact with each other? Should this transaction, whatever changes this transaction is making, before it gets committed, should the transaction 2 starts reading it? That is where things become this one. So we would be talking about isolation levels today. Okay, so am I clear with these things? I would be summarizing everything in Hindi. So summarizing everything out there, not Hindi. I would be summarizing everything in just 1 minute. We have something known as a relational database, and it is made up of rows and columns. Initially, computers started doing accounting, and people used to save that accounting information in ledgers. And due to that use of ledgers, that gave birth to rows and columns like thing. Now, databases are one of the most critical thing out there where we save data. And here we would be talking about the I of ACID and ACID properties of a relational database. What is isolation level when one transaction is running and when transaction 2 is running, how they should communicate with each other. This is what we would be talking about. Am I clear? Or do I need more example? Give me a quick yes or no. Give me a quick one in the chat. Okay. Now let's talk about the isolation levels. Okay. So the very first one is repeatable leads. Okay. The very first one is repeatable reads. Okay. So what does that mean? That consistent read within the same transaction. even if other transaction committed one transaction, it won't see the changes if the value is already read. What do I mean by that? Okay, I would consistent read within same transaction. This just means that, sorry, consistent read within same transaction. This is what is meant by repeatable reads. Let us understand that. Let's say I had a balance of 50 rupees. I had a balance of 50 rupees. When transaction T1 started off, I was having 50 rupees balance. So what it would do is it would take a snapshot of the entire database and it would save. Let me just tell you. Let's say this is user table. This is the user table. This is the user table. And we have the information of two folks. Okay. And the name of the table is user table. The very first one is the ID, it is the balance, it is the phone number, it is the section. So the very first one is, let's say ID of 123 is having a balance of 23 rupees and its phone number is dot 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 whatever and his section is B. Then ID 121 has a balance of rupees 50, phone number is this and section is A. Let's say this, we have something like this. Okay, what happened is, let's say we have written two transaction. We have written two transaction out there. Transaction 1 and transaction 2. Whenever I'm writing a line, it is getting committed. Okay. What happened was this transaction 1 starts. Okay. This transaction 1 starts and it found out the balance of 1 2 3. So if it queries that select, like select balance where ID is equals to 1 2 3. If it selects, the output would be 23. The output would be 23 when this line was written. Okay. Now what happened was, in the meantime, transaction 2 also kicks in. Transaction 2 also kicks in. It says update balance is equals to 50 where ID is equals to 1 2 3. What would happen? Due to this line, this balance would get updated to 50. Okay. Now this line would again select balance where ID is equals to 1 2 3. If it does this, it would get the output as 50. After two lines got executed, then again we again do something like select balance where ID is equals to 1 2 3. If you observe that as of now 1 2 3 has a balance of 50. 1 2 3 balance has changed, but still, this is the most important part, but still here the output would be 50. Here the output won't be 50. Here the output would be 23. This is the most important aspect. That even though transaction 2 has updated something after transaction 1 has started off, still the values out there is not changing. Okay. Like what I meant to say is that consistent read within the same transaction, it means that once the whatever was the value when the transaction started, it would keep up to that value, whatever happens to the database. It doesn't care. Now let me tell you in a nutshell how this is performed. What happens is whenever the whenever the DB's isolation level is set to repeatable reads, it takes a snapshot of the database. It takes a snapshot of the database and it uses that snapshot for the entire transaction. It doesn't query into this database. It queries from that snapshot. That is why whatever changes are done while the transaction is running, it doesn't get reflected to this. And this is what is meant by repeatable reads. So consistent read within the same transaction, even if other transaction committed one transaction, it won't see the changes if the value is already read. Okay, let's just understand it a little bit further by some examples out there. Consistent read isolation level. Transaction isolation level in databases, consistent read. Yeah, read, repeatable reads. See, this isolation level guarantees that a transaction will see the same data throughout its duration, even if other transaction commits changes to the data. However, phantom reads are still possible. What do you mean by phantom reads? Phantom reads are termed as dirty reads. Okay, so non-repeatable read, non when during the transaction is what is phantom read? See, occurs in a databases when the transaction re-executes and receives a different setup. You don't need to know about this as of now, just ignore this term, but this term is very important. That this isolation level guarantees that a transaction will see the same data throughout its duration, even if other transaction doesn't change its commission. So I would again tell you everything in Hindi. Okay, होता क्या है कि जब एक ट्रांजैक्शन शुरू होता है और डेटाबेस का आइसोलेशन लेवल को डेटाबेस के आइसोलेशन लेवल को रिपीटेबल रीड्स में सेट किया गया, यू कैन सेट द आइसोलेशन लेवल्स इन अ डेटाबेस। तो होता क्या है, जब एक ट्रांजैक्शन शुरू होता है तो वो पूरे डेटाबेस का एक कॉपी बना लेता है, ताकि जब ट्रांजैक्शन चले और उस पॉइंट ऑफ टाइम पे कोई चेंजेस आए तो वो कॉपी पे रिफ्लेक्ट ना करे। अब क्या होता है, तब क्या होता है, जब ट्रांजैक्शन चलती है तो वो कॉपी से डेटा लाता है, तो असली डेटाबेस में कुछ भी चेंजेस हो जाए उससे उसको मतलब नहीं। जिस पॉइंट पे जिस डेटा से वो ट्रांजैक्शन शुरू हुआ था वो वैसी ही रहती है। Am I clear to you now? This is what is meant by repeatable reads. Okay, let us move further at this point. Okay. Hmm. This is what I want. Now, let's talk about read committed. Okay, what is read committed? Okay, reads within the same transaction, always fresh value. Okay, repeatable reads within the same transaction are inconsistent. This just means that what would happen if you set the data isolation level to read committed, what would happen? Now, While this transaction ran, it returned 23. Then this line ran. It updated this value to what? 50. Now, what would happen is if you again do the same thing, that is select balance where ID is equals to 1, 2, 3, then it would return you 50. Why? Because repeatable read committed would, okay, always fresh value. Okay, reads within the same transaction always reads fresh value. Okay, this just means that read within the same transaction reads fresh value out there. Okay, reads within the same transaction always reads fresh value. This is what is there. That is why we termed as read committed. Now let's head back. Okay, now read uncommitted means that even though someone has not committed anything, okay, so I would tell you this: read uncommitted. What would it happen? It whenever this balance is updated to 50, and again you query for this, you would get this value, even though this has not committed. Like after this, earlier it was a commit. What do you mean by commit? Commit means a checkpoint to save. In read committed, it would read the values that has been committed by other transaction. But in read uncommitted, even though other transaction has not committed anything, just doing something, it might roll back also. But still, even though it is not committed, it would read this data. That is what is meant by read uncommitted. So read uncommitted, if you observe, is the lowest level of isolation, where even if there is a change in any value and it might just a sec, and it might roll back, even though it is not committed, still one transaction would read it. Read committed is one step further, where even if there is a committed change, then only transaction one would see doing it. Read, repeatable read is something where the data in the inside the transaction, all the data are consistent. Not it is not subject to change with respect to other transactions. That was pretty much about transaction isolation level. So you should read about this. Please don't write Surajit Kumar. Please don't write all this. I would disable the annotations and I would unshare and share the screen. So now, quick, you can give it a read. And system design rounds, this is one of the most asked thing. Data transaction isolation level in databases. This is one of the most asked one. So am I clear till this point? Give me a quick one so that I can move forward. Now we would be talking about something very interesting. I gave you a little bit of dose of like a little bit complex dose. Transaction isolation level is something which is good enough and interesting enough to understand. And now we would be moving forward. Give me a quick one if this thing is clear to, up till this point. Okay. So I would quickly move forward. Okay. Now let's talk about scaling databases. Okay. So if you observe, database are the most important component of any system out there. Okay. Scaling databases. So whenever we want to scale a database, like let's say initially we started off with a very small databases, we had only hundreds of users and things were pretty much. But now let's say our application is growing and we have a lot of data to store. Then we need to think of something. Okay. So let's say we started off with a very small database. Okay. Let's say I'm very bad at drawing. Okay. Let's say, okay. Let's say we started off with a very, okay. Let's say we started off with a very small database, and as of now, we want to store large amount of data. And store a large amount of data means a large amount of data would also be queried. Okay. So if the database is small and we want to maximize the database, I would give you a very small example. Let's say, I am as of now using a 1 GB RAM phone. And I want to handle multiple applications out there. I have a lot of phone dependent work. So what is the first thing I would do? The very first thing I would do is I would I would buy a better phone. That is basically I would buy a better phone, or I would increase the RAM of my phone, or I would increase the storage of my phone. This is what I would do. So from the small database, we moved out to a big database, that is a good phone. Earlier, my phone was not able to handle. Now I moved on to a better phone. And this thing of increasing the specification, okay, is termed as vertical scaling. Okay, we have a vertical scaling. What does that mean? This just as the name such as we have took the example of phone. This is just like add more RAM, CPU, okay, RAM and CPU, or either disk space. Okay. Now, when we are changing up the RAM, when we are adding more RAMs, we need to stop the phone and then increment it. So that is why requires downtime to reboot. Okay, this is very important that I am a very busy person. I want to handle a lot of tasks. Now to increase the RAM, to increase the storage, to increase the disk, I switched off my phone so that I can increase it. And this downtime at that point of time, I'm not able to do a lot of work. Okay, this is the very, but it would give you the ability to handle more load out there. Okay, but there is a problem in that. If you observe in phones also, we see na expandable storage up to 64 GB. We have this line. Then we can see that virtual RAM up to 8 GB. That is the thing. We have a limitation of how much we can scale our phone. In the same manner, every hardware has a limitation of how much we can scale. Like I would give you a very simple example. Let's say I want to walk fast. So I would buy a better shoe. I want to walk faster. I would have a motor out there in my shoe to help me run. But now if I want to increase my speed, I need to change the shoe and buy a bike or a cycle. I can't increase it further after having a motor in my shoes. In the same manner, we have a hardware limitation to most of the things out there. So that is why vertical scaling has a physical hardware limitation. Okay, this is very important to learn. Has a physical hardware limitation. Okay, but now let's say I would I would draw a thing. This would be more feasible. Draw.io. Yeah, draw.io. This would be more feasible. So now say that we have increased the load. Like earlier, I had a lot of application work to do, and then I thought that I'm not able to handle do all the work in this phone. So I increased the specification of that phone and I increased it to the max. But even after that, now I have increased it to the max, but still my work is not enough. I need to increase it further. So what can be done? What can be done in this scenario? Anyone? And where is that networking? Databases. Yep. So we had this initially. We had this. Then what we did was we increased the specification to this. From this, we went to this. From this, we went to this. And now this is the ultimate expanded version of the databases that we were doing. Like we have increased the specification, we have done a lot of vertical scaling. Now this is our new database. This is what we have done. This is our new database. But still this is not working. This is not enough. We need to do more work. So what we do is in this scenario, we observe that the number of account created, like I would define a very small example out there. Let's talk about Flipkart. Okay, let's talk about Flipkart, Amazon, Myntra, anyone. The number of people scrolling Myntra and Flipkart is much more than people actually buying it and adding to the cart. So what I meant is people who are scrolling, they are just reading the data. People who are buying and adding it to the cart, they are writing a data. They are writing a new data. So in most of the application, the read is much more than write. So this is the point where we maintain a copy of the database, where we have maintained a copy of the database. And in here, what is done is, in here, all the read all the read would come to this database. Both have the same data, same amount of data is at both of the places. And here at this point, we have something known as write. So all the write to the application would come at this database and all the read of this would come to this database. So if you observe, we have distributed the load. Earlier, whatever was our capacity, we are now able to do 2x of the time. Okay, so now if you observe, I told you that they both have the same data. So if let's say as of now, let's say Siddharth is having a balance of 50 rupees. So here also it would have the balance of 50 rupees. Here also it would have the balance of 50 rupees. Here it should also have the balance of 50 rupees. That is why this is there. Now, there is a question out there. If there are two things, we need to update data two times. So now let's say Siddharth has recharged his balance. So I told you all the writes would come to this database. Siddharth has recharged his balance to 50 rupees more. Now it is 100. So what would happen is, if Siddharth is reading his balance, he is saying rupees 50. But in reality, Siddharth's data is 100. That is why I would tell you that whenever you change your profile picture in Google, it tells you that we would change the profile picture, but it would take 2 days to reflect in all services. Have you heard this term? That is where they have read replicas different and write replicas different. So this is where what we do is basically whenever there is a write in the database, whenever there is a write in the database, it is also written in the read replica in two manner. One is sync and one is async. Let me explain you both of them. Okay. If you talk about sync, that they basically means when write then and there. Matlab, it just simply means that whenever there is a write in Siddharth's balance, it would, at that point only, it would start reflecting in read also. This is sync. Like that would happen at the same time. Sync. मतलब अभी के अभी उस पे लिख दो. Like whenever you buy Google Premium, it starts reflecting on all your services then and there. That if you observe, Google Premium is a service which is sync. But changing the profile picture is acceptable that from after 1 or 2 days it would start reflecting everywhere. So that is where this comes the point where we say the term async. That means eventually it would reflect in read replica. Eventually it would reflect in read replica. Okay. Whenever sync means right then and there, they both would happen at the same instance. Async means it would eventually have the data as balance as 100. This is where. Now, not just this, let's say even this is not enough. Even this is not enough. So what we have is we start having multiple databases out there. We start having multiple databases out there. Not just this, we would start scaling things horizontally. If you observe, that is why it is termed as horizontal scaling, where all the data like it is having like this are having three write replicas. Let's say our application is having a lot of writes out there. That is why it is having three write replicas and white write replica. If the read is happening a lot, if the read thing is happening a lot, then we would also have read replicas out there. We would also have read replicas out there. So this is where we scale horizontally. And this is termed as horizontal scaling. When we increase the specification, it is vertical scaling. When we increase the number of instances or replicas, it is termed as horizontal scaling. Okay. Am I clear? Give me a quick 1 or 0 in the chat. Okay. Now a very important term out there, a very important term, okay, which is basically sharding and partitioning. What is the difference and what is it? So one is sharding, okay. One is sharding a database. What is basically, I would increase the size. Okay. Sharding a database. What is that method of distributing data across multiple machines? Okay. Method of distributing data across multiple machines. So whenever we distribute data across multiple machine, It is known as sharding. Let's say we have 100 of users and we are distributing data. Like from 1 to 50, it would be in this database. From 51 to 100, it would be in this database. That is why we are distributing the load of each of the database. This is known as sharding. Okay. What is partitioning? Don't worry, things would become easy after some point when you start to learn the difference between the two. That is why I'm just teaching both of them at the same time. Partitioning. Okay. What is partitioning? Splitting a subset of data, but both of them are in the same instance. Okay. This is across multiple machine. Okay. Method of distributing data across multiple machines. Like this is 51, 52. Okay. This is splitting a subset of data within the same instance. This is known as partitioning. Okay. Now, let me give you an example of how a data is partitioned. So, partition versus sharding. I would show you the image. Yep. This image is something which I want. Yep. So, see, partitioning is where partition 1 and partition 2, they both are in the same database. It's just like data is partitioned, but they are in the same database. Sharding is where partition 1 is there in one database and partition 2 is there in second database. That is why I wrote that sharding is method of distributing data across multiple machine. Okay, across distributing data across multiple machine and splitting a subset of data within the same instance. Here, splitting multiple data within the same instance is known as partitioning. So that was pretty much about partitioning, where we split the data into two parts. Split, not two parts, there can be multiple partition out there. And sharding is basically splitting of different partition in multiple machines. That was pretty much okay. This image is good enough to understand. Apart from that, you can do a Google search and you can understand it more. But this is what is asked, that what is sharding, what is partitioning, and what is the difference between both of you. That's pretty much that would be asked from you in entry level. But if you're not an entry level person, you need to dig deep more into this. So that was pretty much from my side, where today we learned about sharding, partitioning, and we learned about database isolation level, where read committed, uncommitted, and repeatable reads. Okay, that was pretty much the idea of today, where we learned about scaling of databases. That was it from my side. I would wait for the next 30 seconds. If you have any concern or queries, you can ask me at this point, else this is a wrap. So I would be waiting for the next 30 seconds if you have anything to ask. Today, comparatively, we are done with databases. Most of the thing out there is done. This is the first time we would be covering OS in today's class or not. No, I finished off with databases. From next class, we would be starting off with operating system. From the next class, we would be starting, like we would first start off with what are threads and all, what are the different types of, what are the scheduling algorithms and all, what do you mean by pages and all, and then we would slowly move forward. Anyone has any concern or queries to ask? Seems like no concern or queries up till now. Okay, that was it from my side. Thank you and have a nice day. Goodbye, everyone.